Good to see you everybody back after a long time. I've been taking a break from Leetcode for some time as I got busy into Rust, which is promising a new exploration into computer languages and which has a completely different way of thinking. I guess before Rust, I never thought a language would excite me so much because you go from language A to language B and you see the same old concepts in a different syntax, but Rust made you kind of use your brain cells after a long time. So I really appreciate Rust, but we'll come back to Rust and you guys will probably see a Rust video from me very soon. But right now, let's do a lead code problem which is extremely important. It is asked by many companies. It is not a repeated substring pattern. It's a very easy problem to explain. All you need to do is find a substring within a string, uh, uh, which is and the resultant string, the input is a multiple of that substring. So basically, for example, he gives you example AB AB, and he says it is a substring AB repeated twice, right? So same thing is ABA. Here you see in ABA, you see that there is no such pattern, right? And here in the last example, you see that it's nothing but a multiple of the substring ABC. So it's all given a string as check, which can be constructed by taking a substring of it and appending multiple copies of the substring together. So let's try to do this problem in C++ and see that because C++ is getting more giving us zero cost abstraction, just to use Bazar and Strostrup's way of thinking. He says that C++ gives you code that is fast as well as gives you built-in data types, built-in abstractions, so you don't have to take a compromise between uh, Python and shell script, or Python versus C. You can get Python kind of data structures in a C kind of syntax. And not only that, it's almost close to the metal in the sense that it's a fast code, unlike Python, which is a language which is interpreted. So let's do that without much further discussion on this topic. So here we have string as is given to us. How shall we approach this? My approach is to start with a string v, which is a vector, and now this is a local string. Now uh, do we have to initialize it? I'm wondering, because I don't like uninitialized variables at all. So let's initialize it. Then let's define another string temp, or temp rather we will define a little bit later. But right now our approach is we go from for I equal to 0. Oh, okay, no. What we will do is we'll use C++ style of for auto reference C. Basically walker and the walked. The walker is the C and walked is the S. So we'll walk, and what do? We just take one character at a time and keep into this string v. So you say v equal to plus equal to c. Okay, so now v is just one character this time. Now we see we have a local string temp. So let's construct. The reason why I wanted to do this here rather than at the function scope is that I don't have to want to do the work of freeing. The freeing can be done by the compiler by its scoping rules. So string temp, let's say there is a string temp, and we have now this will be used very soon. So now we has right now only one character. Now we put a while loop and we say while temp dot size less than or equal to s dot size. What do we do here? We have another loop. So what does this loop do? This loop we do a temp plus equal to v. So temp plus equal to v. So basically we try to make multiple, think about it, it's like adding more and more of v's into temp until the temp size is less than s size. And anytime we do that, what do we do? If we see that after we add only one temp here, see, we see if temp equal to size s, then what do? We return temp, because that's the substring we were looking for. Now right now you remember that the temp still has only one character. We are taking one character at a time. If we don't return here, what happens? If we don't return here, we go back to the for loop, and in the for loop we see that v is not changed, v is from the previous time, but we add one more character from s into v. So now, and then the temp, as you know, temp gets, if we don't return here, then you see after the while loop temp is because it has for this block scope, you see that when the for loop starts, temp is again refreshed, the previous temp is gone. So previous temp is gone. So now with this, let's see if it sounds like this should work, unless I'm missing something. So temp dot size less than, oh okay, here we need a bunch of brackets. So here we are, temp plus equal to v, and if temp equal to s, then we return temp. Now let's see if we run it, what happens. We have a compile time error, no viable conversion from return value of std string to function return type bool. Okay, so here we have a problem. The problem was he wanted bool, not the string. So you say if temp equal to 2, you say return true. Now let's run it again. Control reaches end of, here we say all control error non-return. Line 15 we have a problem. Line 15, the problem is non-void function doesn't return a value. So if temp equal to s, return true, else I think it should return false after the for loop. If we haven't returned in the for loop, we have to return false, right? So we have to return false. That's why it's complaining. Let's run it again. Wrong answer. Why is it wrong answer? Because ABA, he says expected false and you return true. Why did this happen? Is this happen because we are using equal to sign? Wrong answer again. We got output of true, we return true. Why? Now let's see what's going on here. So string v plus equal to c. So right now while temp dot size is less than or v s dot size temp equal to or plus equal to v. Okay, so we construct this, try to see if temp plus equal to v, if temp equal to s. So we add v into temp, we keep adding v into temp, and you said true but expected was false. So what is going on here? We will try to see what is the problem. So let's see. So while temp v plus equal to c or pushback, whatever the heck, it doesn't matter. When we go, we keep. Okay, let's try to see what is here. Let's do a count and see what is v now. Count v here. Okay, now let's run. Output is true, but there. Okay, so now what did we print here? We say a. So what was the input here? Input was ABA, right? So we should have constructed to see if the whole string is nothing but made of only A's, then AB's, and then ABA. But actually we got more than that. We got A, and then we got ABA, A, and then BA. So what is going on here? I think the thing is, while temp dot size is less than s dot size, if temp equal to s, temp keep building into temp. So we're saying string temp. Okay, so I think one problem I can see is when we go here, temp is an uninitialized string on the in the local scope. It would have been nice if we did temp equal to this, right? Now let's see. Still we got a wrong answer because you written A, B, A, B, A. Now what is the problem here? So temp dot size, obviously in the beginning when we come, temp dot size is v is only one character is added on v, and temp dot size is less than s dot size. So obviously it is true. So if that is true, we come inside, we say temp plus equal to v, and temp plus equal to v makes the temp now equal to first character A. Now we say if temp equal to A, no, it's not true, return true. Otherwise we'll go back and we say if temp dot size, yes it is. Then what do? Then we say, hey, is it temp plus equal to V? We add the next character AB. So now it is AB. If temp equal to S, no, we go back, we add one more character. When we go, we add one. So what is the V? We should say what is before the for loop starts. What is the V? So here we say end L, count V end L. Now let's see this time. Of course we know it's going to be wrong, but we want to see. That's the whole idea of debugging. So we started with A, that is good. Then we started with AB, and then we say A is the whole string, nothing but bunch of A's, and we kept adding here, you see. Okay, and then we saw it's not true. So here, why did we return true? I'm really surprised actually. If temp equal to s, return true. Let's see. So I think what is happening. We are getting a, if temp equal to s, we have to return false, right? that's, you are assuming that the temp at this point is a subunit of s, but you're not assuming that, hey, we couldn't find a subunit and we ended up having the whole thing. Obviously the whole thing will be equal to the subunit. If the subunit is equal to the whole thing, it will be equal to the whole thing. So we say if temp equal to s, we say return true. So even if ABA is only made up of one of ABA, it returns true. But he's saying no, in this case we couldn't find a substring smaller than s. So by taking a substring of it. So if you think about it, I think it should be less, right? It should be less. Okay, okay, here let's get that guy out now. Save. So when ABA happens, when the string becomes equal to, it basically gets out, and when it gets out, we have to see if we were unable to find. So as long as it was less than s dot size, we were okay, while temp dot size is less than s dot size, temp plus equal to b, right? If temp equal to s, return true. No, it's not true here. It has to be only if temp is equal to s, and if I say and temp dot, sorry, and you say v is not equal to temp, and v not equal to temp. See, I think that's what would be, because you see temp equal to s, but if v is equal to temp, then it's not really true, right? There you go. So that was the problem. The problem was that temp, we couldn't find the substring, so we logically we found the original string to be the only substring, quote unquote substring, and we thought, oh, that's true, return true. So it should be, the logic should be if temp, so the subunit that we built is equal to s, that means we were able to get to s just by repeated by the repetitions of v, but v is not equal to temp, the thing that we built in. Then yes, we found a subunit within s whose multiple s is. So otherwise it's not true. So now let's try to submit and see if it works. Output limit exceeded. Why? Oh, I see. So we need to remove this count, otherwise we'll have a problem. Output limit exceeded. Okay, run again. Accept it. Submit. Time limit exceeded. Why? Because they gave you a huge string and you basically you just ran out of time, because this algorithm is a crappy algorithm basically, if you think about it. Why is this a crappy algorithm? Because first of all, you got a for loop outside on the original string. So if this string is a million, imagine this string is a million. Now this string is a million. On top of it, you got a while loop too. Imagine you got for each of this you will go inside, you will try to build this v substring. You will try to then see if string temp is a while temp size. So now you see is a on square solution and it's not very good. How can we make a solution that is on so that it doesn't have time limit exceeded? So I leave that as a exercise for you guys, because otherwise there's no fun in programming. If I just give you the whole solution, it is not very exciting. So you saw that the solution is right. So if you, let's go back here, see test case 1, run. It works. Test case 2 is run. So test case 2 input was AB, output is true. Okay, good. Yes, it is. Okay, test case 3, let's see. And that also works, right? So as you know, all the test cases are passing. Like here now s equal to a b c, and let's say run. And of course it passes, right? And expect. So all the test cases are passing, but when you do a submit, it says time limit exceeded. And I know why that's happening. I think because you have on square solution here. You're walking from the on the given string, and within that given string you have one more while loop. You have a loop within a loop, and you never want to do that in an ideal world. So I will leave that to you guys as an exercise to make it in such a way that the time limit is not exceeded. So that means you need to change the algorithm, and that's where the fun starts. So rather than suggesting you a new solution right now, I would have you explore from this suboptimal solution to the optimal solution. And with that, I will say goodbye for today. Hope to see you in a Rust video very soon. Bye bye.